Many people that take out a loan for things like a car or a home do not pay on the loan for its entire term. Rather, they pay off the loan early by making a final lump sum payment. When the number of payments is large, we may want to find the unpaid balance of a loan without having to create an amortization schedule because that could take a really long time. For example, a lot of times people take out home loan mortgages on houses and they have to pay that off for 30 years. So that means that if you're paying monthly on a 30-year loan, in total, you'd have 360 payments. And so if you made an amortization schedule, if you wanted to know how much the unpaid balance is after like 25 years, that means that you would have to make an amortization schedule and go down 25 times 12 rows, which is 300 rows. So you'd have to fill out 300 rows of an amortization schedule to figure out the unpaid balance. However, there is a formula for that. So let's look at the formula. So for a loan of N payments of R dollars per period at an interest rate I per period, the unpaid balance or the payoff amount, it's sometimes called, after K payments have been made is the present value of an ordinary annuity with N minus K payments. Another way of saying that is with N minus K payments remaining, we have that formula there, and A sub N minus K represents the unpaid balance. So let's look at example 4. It says a young woman decides to stop using a credit card after she acquires an outstanding balance of $15,000 with an interest rate of 18% compounded monthly. She makes monthly payments of $270.28, which will pay off the debt in 10 years. After 6 years, she gets a new, better paying job and decides to pay off the unpaid balance. Find the unpaid balance after the 72nd payment. So A sub N minus K is equal to, I'm just going to rewrite the formula that we have above, the regular payments times the quantity 1 minus 1 plus I to the power of negative N minus K all over I. Okay, so let's see if we can't figure out some of those values. We know that the regular payment amount is $270.28. We know that the annual interest rate is 18%, but it is compounding monthly, so we want to divide that by 12. And if we do that, we get 0.015 as our I value. And then we know that in total, if it's monthly for 10 years, we know that the N value will be 12 times 10, which is 120. And K represents 72 because we want to know how much it's going to be after the 72nd payment. So then N minus K would be 120 minus 72, which is going to equal 48. So if we plug in all of those values here, we'll get $270.28 times 1 minus 1 plus 0.015 to the negative 48th power all over 0.015. And if you throw that number into your calculator, that means that after she gets this new, better paying job, after 6 years, if she wants to pay off the rest of her credit card debt in one final lump sum payment, that amount is going to be $9,201. So that will be her payoff amount after 6 years or after the 72nd payment. That's just another way of saying that. So refinancing is the replacement of an existing debt obligation with another debt obligation under different terms. There are multiple instances when a person might want to refinance a loan. Some examples are taking out a new loan that has a lower interest rate. If the borrower now has more money, so they put more towards a down payment of a new loan and changing the length of the loan to pay something off faster. These are just a few examples of reasons why someone might refinance a loan. So let's look at example 5 now. It says 4 years ago, Benin Corp decided to expand its production capacity and borrowed $1.3 million for 20 years at 5.2% compounded quarterly. After making 16 quarterly payments of $26,235.37, Benin Corp is considering refinancing this loan for 15 years at 4.8% compounded quarterly with refinancing charges of $5,000 added to the amount of the new refinanced loan. Part A asks us to find the payoff amount of Benin Corp's original loan. So this is where we would use that formula that we saw in the previous page. So n is equal to, we know that the payments are happening for 20 years quarterly, so that means 4 times a year. So the total number of payments will be 80 payments. And k, we know that they ended up making 16 quarterly payments. So n minus k will be 80 minus 16, which is 64. We know that the regular payment amounts are $26,235.37. We know the annual interest rate is 0.052, and that's happening 4 times a year. So if we divide by 4, we get 0.013 as our I value. So now A sub n minus k is going to equal $26,235.37 times the quantity, 1 minus 1.013 to the negative 64th power divided by 0.013. So if you throw that all into your calculator, you get $1,135,148.82. So this represents the payoff amount of the loan after 16 quarterly payments. Okay, so part B says find the amount of the new loan and the new quarterly payments. Well, we did most of the work in part A to find the amount of the new loan. Since this represents our payoff amount, we would need to take out a new loan in that amount, but we would also have to add in the refinancing charges of $5,000 into that and add it to the amount to figure out the amount of the new loan. So the amount of the new loan, A sub n, would equal the payoff amount of the original loan plus the refinancing charges to give us $1,140,148.82. And then after we figured that out, now we want to figure out the new quarterly payments. So this is where we would plug a bunch of values into our formula. Let's figure out some of the variables that we want to plug and chug first though. So for the new loan, it'll be financed for 15 years at 4.8% compounded quarterly. So our N value, or the number of payments, is 15 years, 4 times a year. So the total number of payments would be 60. And then our annual interest rate is 4.8%, but that's paid quarterly. So our I value would be 0.012. So now we have a bunch of values we can plug into our formula. So we get R is equal to our A sub n value times our numerator is going to be I, which is 0.012, and our denominator will be 1 minus 1.012 to the negative 60th power. And if you throw that into your calculator, you should get $26,766.30 as your new quarterly payment. Okay, so the last portion of this question says, should Corp refinance? And at first glance, it seems that Corp should not refinance because the new payment is higher than the original. So here is the new payment. So it's $26,766.30. And the original payment was slightly less than that, $26,235.37. However, if we look at what the company will be paying overall, we have the original loan and we have the refinance loan. So again, just to reiterate, even though the refinanced new quarterly payment is a little bit higher than the original quarterly payment, we can see that the refinance loan is a little bit shorter since it's 4 quarters less. That means you would pay off your loan a year sooner. And overall, after you look at the overall payment, at the end of the day, the refinance will save Corp about, if you subtract those, $73,085.68 will be saved with the refinance, as well as 1 year sooner that is not a good sentence. Let's rewrite that and say they will also repay the loan 1 year sooner with a refinance.